All right, so number 31, it says the model represents an equation. Keyword equation. So I'm going to have to do an equation, and I noticed that there are variables on both sides. So that's going to be fun. It says which value of x makes the equation true. So let's see. I've got negative 3x's, so it'll be negative 3x. And I've got 2, 4, 6, 8, 10 ones, so plus 10. This one says 1, 2, 3, 4, 5 x's. They're all positive, so 5x. 2, 4, 6, 8, negative 1, so minus 8. It says please record your answer and fill in the bubbles on the answer document. Be sure to use the correct place value. This is going to be a griddable. Many of us get the right answer but don't bubble it in correctly. So please, okay, focus on where your decimal is and then bubble it in correctly. All right, here we go. This is an equation you can put in your calculator. You can solve it using a couple of steps on your calculator. You can solve it using Desmos, or you can solve it by hand. I'm going to choose to solve it using Desmos just so you can remember how to do this. Desmos is a tool you are allowed to use on STAAR, so you might as well practice it, right? All right, first thing you do, you're going to take this equation and plug it into line 1. So desmos.com/practice. I'm in Texas STAAR mode, and I'm going to type my equation in. Negative 3x, and then it says plus 10. If you notice, that line graphs, okay? So it graphs the line for you. Then I'm going to go here to the next line, and I'm going to type in 5x minus 8. Both of my lines are now graphed. My answer for x is going to be where these two lines meet. Notice I've got a point. Your answer is going to be the x value of that point. So in this instance, the x value is the first number in the pair. So the point or the answer or the value of x is going to be 2.25. So if I was to bubble that in, 2.25, and I had a griddable, and there's where my decimals were, okay? I need to pay attention to what numbers are where, and then it'll have one more right here that has a positive or a negative sign. I know my answer is positive, so I'm going to bubble that sucker in. And then I know that my number, I've got 2.5 behind the decimal. So there's my decimal. So behind it, I'm going to put a 2 and a 5. And I've got a 2 right in front of it. So that 2 is going to go right there. Bubble in wherever your circles are. Because even if you write it here, it's not going to count unless you bubble it in. Okay? So you're going to have that 2, and that 5 bubbled in order for your answer to work. Okay? All right. Number 32. The diagram below shows the side view of a ramp used to help load and unload a moving van. Which measurement is closest to the length of the ramp? Okay, here's a right triangle. Whenever I have a right triangle, I use my formula chart. I know when I have a right triangle, I use the Pythagorean theorem. And the longest side is C. So let's see. I've got a 3 and a 4. The longest side seems to be missing. So that tells me I'm going to use a squared plus b squared equals c squared and try to find c. All right, cool. Let's plug in. 3 squared plus 9 squared is equal to c squared. Okay. So I'm going to use my calculator, type that in. 3 squared plus 9 squared. 3 squared plus 9 squared is 90. So 90 is equal to c squared. On your formula chart, something you need to remember to do is always take the square root. So I need to remember, I need to take the square root of whatever c squared is. So go back to my calculator. Second x squared, type in 90. So 9.48, but remember in 8th grade, well, it's 9.48683, whatever, blah, 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 blah. In 8th grade, we only have 2 numbers after the decimal. So that's 6 after that hundredths place is going to tell me what to do. 5 or more, raise the score. 4 or less, let it rest. That's a 6. So that means I'm going to raise that 8 up to a 9. So it becomes 9.49. Which measurement is closest? Well, which one is closest to 9.49, everybody? Boom. All right. Which representation of a transformation on a coordinate does not preserve congruence? Not is your keyword. In this one, I am going to have to find transformations, right? I'm going to have to figure out which one does not keep the same size and shape, because that's what congruence means. Same size, same shape. So I'm looking for the transformation that changes one of those. I have to know my rules in order to know that. So this one, it says 1 over 7x, 1 over 7y. This looks like a dilation. I know dilations make shapes, based on my formula, not my formula chart, my brain dump, make shapes larger and smaller. So that means they change the size. So this one is not gonna preserve the congruence. It's not gonna keep it the same size, same shape, because it changes size. So this one automatically is my answer, but let's keep going. Identify your transformations. This one says x plus 7, y plus 7. The one that adds is translation. With a translation, it's a slide. So I move it up, move it down. That doesn't really change the shape or the size. It just changes location. C, x and y goes to x negative y. That one looks like a reflection over the x-axis. But when I reflect, I don't change the shape or the size. I simply change the location and orientation, aka direction. So that was not it. That was a reflection. And then this one, it says xy to y comma negative x. Well, when they switch places, I know that that's a rotation. And when I rotate something, even if I rotate this paper, it's still the same size. It's still the same shape. It's simply going in a different direction. So that one couldn't be my answer either. $34. A tree in Dante's neighborhood grew 18 inches in the first 2 years. After it was planted, excuse me. If the tree continues to grow at the same rate, which graph best represents the growth rate of the tree in inches per year? Here's the thing. Rate. Uh-oh. I'm going to deal with rate of change, also known as slope. Okay? Here's the deal. I know that slope has an equation. It can either be written in y equals mx plus b or y equals kx form. So just for giggles, I'm going to put y equals mx plus b here. And I'm going to see if I can find an m and a b. Okay, it says grew at 18 inches in the first 2 years after it was planted. So if it grew 18 inches in 2 years, in order to find slope, remember for direct variation, we put y over x. So let's put 18 over 2 and see what we get. 18 divided by 2 is 9. So it seems like this is a direct variation equation. It seems like it's growing 9 inches each year. So it wouldn't be plus b. It would simply be y equals 9x. I need to remind myself, when it's direct variation, it is proportional. It goes through origin. All right, let's get this in. I'm looking for the ones that go through the origin. Origin, origin. Ooh, not go through the origin. Origin. Okay, I got rid of one. Awesome. Let's keep going. It's growing 9 per year, so let's make our own little table. So, X and Y. Let's say it's 0. Did it grow? No, because it hadn't been a year. So 0, 0, that's what makes it proportional. Year 1, in 1 year, it should have grown 9 inches, because here's my equation, right? 9 times 1, 9. 9 times 2, 18. 9 times 3, 27. All right, let's see which one matches our graph. So 0, 0. Boom. 1, 9. No, that one didn't hit it. That one's out. Let's try this one. 0, 0. 1, 9. 2, 18. 3, 27. Uh-oh, that one might work. Let's try J just in case. 0, 0. 1, 9. Oops, it's out. So our answer was J, or G, excuse me. All right, and last one for this set. An artist joined 3 square regions at their vertices to create the figure shown in the diagram. Notice what's in the center. A right triangle. So this is telling me A squared, see, there's a square, plus B squared, there's a B, is equal to C squared. There are my squares. Many of you wondered why it was A squared plus B squared equals C squared. Because I create an actual square. Okay? So with that in mind, remember, this says A squared, B squared, C squared, just with different letters. So here we go. It says the artist used small congruent square tiles to cover each region without any gaps or overlaps. Nobody really cares. Based on the information, which statement is true? That's what you need to answer. Look at A. The number of tiles needed to cover X, okay, so note, identify where X is the same number of tiles needed to cover both Y and Z. If I add these together, will I get that? Not at all. That'll be too much. So A is out. The number of tiles needed to cover Y, so I need this one, is the same as the number of tiles needed to cover X and Z. If I add these two together, will they add to make this one? Absolutely not. It'll be too much. The number of tiles needed to cover Z is the same as the number of tiles needed to cover X and Y. If I add these two together, will they add and combine to create Z? If I square this and square that, they've got to, because A squared plus B squared always gives me C squared if it's a right triangle.